So I mentioned in the last video on aiming in Halo MCC that there's a quirk in the way the two dead zones interact, and here's what I found. If you have both axial and radial dead zones on at the same time, the axial dead zone will be correct, but the radial dead zone will be larger than it should be. As a reminder, the axial dead zone is square-shaped with cardinal guiding, and the radial dead zone is circular with no guiding. Axial as in axes, and radial as in radius. For more on what they are and how they behave, the last video goes into much more detail, link below. The number you set the dead zone to more or less correlates to the percent at which you have to tilt the stick before you start turning. The default setting of 12 means that you have to tilt the stick 12% of the way. While this is true for axial at all times, it is only true for radial if axial is set to 0. So how can we find the actual size of the dead zones? Well, I've taken some readings and here's what I've got. Find your axial setting at the top, read down to your radial setting, and you've got the actual threshold of the radial dead zone. This is where the radial dead zone actually is on the controller, regardless of what your setting is. Obviously, there are a lot of blank spaces. I'm not going to test all 441 possible permutations, but you can see the trends and can calculate the threshold yourself for any combination of settings. If you add the values of both the axial and radial settings together, then subtract a number from 0 to 4, you'll find the actual radial dead zone threshold for those settings. The number you need to subtract depends on the colour of the cell. The darker green the cells, the bigger the number you have to subtract. With the lightest green, you don't need to subtract anything. The actual threshold is simply the two settings added together. At the bottom right, with the darkest green, you subtract 4 from the sum of the values. Dead simple. So if the cell for your settings is empty, you can find the answer yourself. By default, both dead zones are set to 12. This gives you an actual axial dead zone of 12% and an actual radial dead zone of 22%, just as an example. If you want to visualize what this looks like, there's a link to the graphs I've been using below with sliders that you can use to vary the size of the two dead zones. This won't calculate the actual radial threshold for you, you'll have to find the threshold yourself with a spreadsheet, then plug in the answer to see the result. By default, it shows what an axial and radial of 12 looks like. Try it out. Alright, what can we do with this? Well, the maximum you can set a dead zone in the MCC is 20%, but the older games had dead zones that were larger than that. I personally prefer as small a dead zone as possible without causing drift, but you may be used to having more dead zone than that. So here's which settings to use if you want to match the old games. Bear in mind that the physical travel distance of the Xbox One stick probably doesn't match that of the Xbox and 360 sticks, so while these numbers are accurate, your muscle memory may disagree. Halo CE and Halo 2 had an axial dead zone of 27, with no radial. Obviously, set axial to the maximum of 20. If you then set radial to 9, the radial threshold will match at 27%, though keep in mind the circular shape has less travel in the diagonals, and the cardinal guiding is stuck at 20. Halo 3 and ODST are very much the same, with an axial dead zone of 26, so just drop your radial to 8. Halo Reach had an axial of 12 and a radial of 23. You can match this exactly with an axial of 12 and a radial of 13, so the new default is pretty much the same. These settings also work for Halo 4 and, surprisingly, Halo CE Anniversary, which all have the same dead zones. Halo 5 Guardians is the only other game here with a variable dead zone setting, ranging from 0 to 15. However, this number is basically arbitrary, unlike the MCC. The inner dead zone setting will vary the actual radial threshold between 13 and 26%, and regardless there is always an axial dead zone of 12%. At a setting of 0, you have an axial of 12 and a radial of 13. At a setting of 15, you have an axial of 12 and a radial of 26. Here's your homework. If your Halo 5 inner dead zone is set to 10, what should you set your MCC dead zones to in order to match it? So there we are. Again, you can find the threshold spreadsheet and the interactive graph in the description below. My name is Stefan, thank you for watching.